Solve the following systems of equations algebraically and check using your calculator. So I want to solve these systems algebraically and then check on my calculator. So when we solve these 3 by 3 systems, we use elimination. Our first step is to make it an Algebra 1 problem. So I need to pick two of these equations, add them together so a variable eliminates, so I'm just left with two variables. And luckily with this first equation, this first system, it's pretty easy to eliminate whatever you want. I'm going to go with eliminating the x's because that seems like the most straightforward, but the y's wouldn't be that terrible to do. Neither would the z's be because you have that one y that you could multiply and that one z that you can multiply to whatever you needed. But let's stick with the x's. So I'm going to do 1 and 2 first. But I've got a 2x here, so I'm going to make this top equation a negative 2x by scaling everything up by negative 2. I'm going to take each term in this equation and multiply it by negative 2. So I have negative 2x minus 4y plus 4z equals positive 30 because I multiplied each term by negative 2. And I'm just going to rewrite the second equation because I don't need to scale that up by anything. And when I add those together, my x's add to 0, they eliminate, and I'm left with negative 3y minus z equals 9. Now I'm going to look at the first and third, because that's going to be pretty straightforward to do because they both have that x there. But I am going to have to make one of them negative. So I'm going to multiply the bottom equation here by negative 1. I'm going to change everyone's sign here in this bottom equation. So plus 4y minus z equals negative 18. So when I eliminate my x's there, I eliminated x over here, which means I have to eliminate x over here. I'm left with 6y minus 3z equals negative 33. Now here's the neat thing. If you look at this equation, I could divide everything by 3 if I wanted to. I'm not going to for the sake of this video, but you could make this problem easier if you divided everything in this second equation here by 3. So now let's solve the Algebra 1 problem. Negative 3y minus z equals 9, and 6y minus 3z equals negative 33. I need these to eliminate, so I'm going to multiply the top equation by 2, because that will give me negative 6y minus 2z equals 18, which means my y's will eliminate very easily, and I'm left with negative 5z equals negative 15, which implies that z equals 3. We haven't finished solving the Algebra 1 problem yet because I have to plug that back into one of my two equations. So I'll do negative 3y minus z, which I now know is 3, equals 9. Negative 3y equals 12, which means y equals negative 4. And I'm going to take both of those values now and plug them back into one of my originals back here. I'm going to pick the first one just because that looks the simplest. X, I don't know what that is, plus 2y plus negative 8 minus 2z minus 6 equals negative 15. So x minus 14 equals negative 15, which means x has to be negative 1. So the solution to my system of equations here is negative 1, comma negative 4, comma 3. That's the order triple where these three planes intersect. Or you could just write it as x equals negative 1, y equals negative 4, z equals 3. How do I check this on my calculator? So on your graphing calculator, we're going to use a matrix to check this. We're going to hit second matrix. I need to go over to edit because I want to put in the numbers into this matrix. For Algebra 2, we're always going to have 3 rows and 4 columns, so 3 by 4. And now all I'm going to do is I'm going to retype in this system of equations, but kind of drop out all the variables, just type in the coefficients. So for example, that first equation I'm going to type in for the first row, 1, 2, negative 2, negative 15. So 1, 2, negative 2, 15. Negative 15, I need to change that too. So let's go back. Let's go back up over there and change that to negative 15. Now I type in the next row. The next row is going to be 2, 1, negative 5, negative 21. So 2, 1, negative 5, negative 21. And then the last row is going to be 1, negative 4, 118. 1, negative 4, 1, positive 18. So the first column represents our x's, the second column represents the coefficients of the y's, the third column represents the z's, equals this last column represents the Plano numbers. So quit out, second quit. I'm going to go back to second matrix, math, scroll down to option B, our REF, the reduced row echelon form of that matrix. Again, you don't have to know what this is, you just need to know how to do it so you can check your work. And then I go back to matrix and I hit matrix A. And it tells me x equals negative 1, y equals negative 4, z equals 3. X equals negative 1, y equals negative 4, z equals 3. So this column here tells you x, y, and z. So it does check out. This last system here, solve this system algebraically. So I need to find what variable do I want to use to eliminate, and I think I'm going to use that negative z there to my advantage to eliminate my z's. The y's wouldn't be that bad to do either. X's you could do. Again, you can always eliminate whatever variable you want to eliminate, but try to be a nice lazy mathematician and pick the most efficient one. So I'm going to rewrite the top equation because I'm going to use that equation as it is. And I need a negative 3z, so I need to multiply everyone here by 3. So I get 18x plus 12y minus 3z equals 60. Eliminate my z's, and I'm left with 21x plus 13y equals 68. I eliminated z, which means I need to do it again. There's a couple ways I could do it. I could use the first and the second, or I could use the second and the third. I'm going to use that negative z again to my advantage and say negative 5x plus 3y plus 6z equals negative 4, and 6x plus 4y minus, I need to multiply that by negative 6. I can't just write that equation as it is. I need to multiply everyone here by negative 6. By positive 6. That way I end up with a negative 6z here. So 36x plus 24y minus 6z equals 120. I multiplied everyone in that bottom equation by 6. My z's eliminate, and I'm left with 31x plus 27y equals 116. So now I've got a nasty Algebra 1 problem down here. This is no way a nice problem. Computation, it's not hard to do. The computations just get nasty. So I need to solve this system of equations. And the best way that I can go about do it is by using elimination. So for the sake of it, they're both going to be just as hard to eliminate. Let's eliminate our x's. I'm not even going to try to think of what's the least common multiple of 21 and 31. So let's multiply that top one by negative 31 and the bottom one by 21. So 21 times 31 gives me negative 651x plus, I'm using my calculator here, minus, not plus, minus 403y equals negative 2,108. Now for the bottom one, I should get 651x. 21 times 27 is plus 567y equals 2,436. I eliminate my x's, and I have 567 minus 403. 567 minus 403 gives me 164y equals 328. This is the moment of truth here. Divide by 164, and we get y equals 2. So y equals 2. We still haven't solved the 9th grade Algebra 1 problem, so plug that back in up here. 21x plus 2y. 13 times y is 26 equals 68. 21x, when I subtract that over, equals 42. So that tells me x equals 2. So x equals 2 and y equals 2, we now have to solve the algebra 2 problem, take both of those and plug them into one of these equations up here. I'm going to pick the first one, 3x. 3x's, 3 times 2 is 6, plus y plus 2 plus 3z equals 8. Well, I have 8 plus 3z equals 8. 3z equals 0. So z must equal 0 then. So what's my solution? 2, 2, 0. X, y, z. Or you could write out nicely x equals 2, y equals 2, z equals 0. Either of those work. How do you check this on your calculator? Go to your calculator, and I now need to edit my matrix. So I'm going to hit second matrix. I want to go over and edit it because I have to put in these new numbers here. The first row, it's still 3 by 4. The first row goes 3, 1, 3, 8. 3, 1, 3, 8. The next row, -5, 3, 6, -4. -5, 3, 6, -4. And the final row, 6, 4, minus 120. 6, 4, minus 120. So matrix A now represents the coefficients that I see in my system of equations. I'm going to quit out of there. Second matrix, scroll over to math. I want to do the reduced row echelon form option, which is RREF, option B. Well, what matrix do I want to do that to? Second matrix. The first one, I put it in matrix A. So enter, enter. And I get 2, 2, 0. Over here tells me my solution. You'll always have that diagonal of 1s and then 2, 2, 0. So x equals 2, y equals 2, z equals 0. So make sure you know how to use your calculator because you can at least get the answer to the system of equations and then just have the work support that answer. Or if it's a multiple choice question, you're done. Type in the system, use the reduce row echelon form button, option B, and get the answer.